All right, let's talk about the SINUMERIK 1. We all know the hardware is powerful, but today we're going a step further. We're going to build its mind, the actual PLC program that makes a machine tool wake up and get to work.
So here's the big question, right? How do you actually build a machine's mind from scratch? You see, the SINUMERIK 1 controller, it's like the super powerful brain, but right out of the box, it's a total blank slate. To get it to do anything useful, it needs a mind. And that mind is the PLC program. And guess what? We're going to build one together, right from the very beginning.
So what are we actually talking about here? What is a SINUMERIK 1 PLC program? Well, think of it as the machine's central nervous system. It's all the custom instructions you create in the TIA portal. It's the thing that organizes all the signals, all the data. Basically, it's the critical link between the controller's brain power and what the machine actually does out there in the real world. Okay, so to build this thing, we need a plan. Here's our roadmap. We're going to start by prepping our digital toolkit. Then, we'll configure the hardware blueprint, integrate the core program, create our custom logic, and finally, take it from virtual to real. Let's dive in.
First things first, you can't build anything without the right tools. So, we're starting by preparing our digital toolkit, getting all our software lined up and ready to go. All right, in your digital toolkit, you need two things. These are absolutely non-negotiable. First, of course, is SIMATIC Step 7 Professional. That's your main workbench. But the real secret sauce here is the SINUMERIK 1 TIA Portal Toolbox. And I really want to stress this. This is not optional. It's the magic ingredient that adds all the SINUMERIK hardware into your catalog, gives you the basic program libraries and tools like the NCVAR selector. Honestly, without it, you're just looking at a generic programming environment, and that's not going to work.
Okay, software's ready. Now it's time to pour the foundation. We're moving on to configuring the hardware blueprint. This is where we digitally build our machine before we even think about writing code.
So, step one is pretty straightforward. We've got to add the brain of the whole operation. We just head over to the hardware catalog in the TIA portal, and remember, all the right parts are there now because we installed that toolbox, and we just drag and drop the SINUMERIK 1 controller into our project. Simple as that.
But, a brain on its own can't do much. It needs eyes, ears, hands. So next, we add all the peripherals. We're talking about the I/O modules, the things that read sensors and actually make the motors turn. Then we digitally connect everything, hooking it all up to the controller with Profinet. What you end up with is a perfect digital twin of your real machine.
All right, last step for our blueprint. We need to give everything an address. Think of it like a house number and a street name for every single component. We assign unique I/O addresses and device names. Why? So there's absolutely no confusion. The controller knows exactly who it's talking to at all times. It's all about creating a system that's organized and, most importantly, reliable.
Okay, our hardware blueprint is done. Now think of it like building a house. The foundation and framing are up. Next, we need to install the plumbing and electricity, right? That's what we're doing now by integrating the core program. This is the essential operating system that handles all the heavy lifting in the background.
So it's really helpful to think of the whole program as having two parts. On one side, you have the PLC basic program. This is the foundation, the stuff Siemens provides in the toolbox. It handles all the standard communication between the NC and the HMI. You just copy it in. On the other side, you have the PLC user program. Now this is your playground. This is where you create your custom logic from scratch to make the machine do its specific, unique job.
Now, that basic program keeps everything tidy by using what are called reserved blocks. And listen, the official list in the manual is massive, so don't get overwhelmed. This is just to give you the basic idea. For example, a block like FC2 is basically the main on switch. DB10 works like a shared mailbox for messages between the NC and the PLC. And FB2 is a special little tool that lets you read a variable right from the NC kernel. These are just some of the pre-built tools your own program is going to use.
All right, foundation's poured, utilities are in, now comes the really creative part. This is where we get to build the custom logic that makes our machine special. It's time to create the user program. So how do we actually do this? Well, we start by creating our own organization blocks, or OBs. These are like the main chapters of our program. You'll have something like OB100 for everything that needs to happen at startup, and OB1 for the main loop that runs over and over. Then, inside these blocks, we have to call those important functions from the basic program, like FC1 and FC2, to make sure everything is connected properly. After that, it's all you. You'll write the logic for the control panels and build custom blocks to handle your specific axes, spindles, all the unique parts of your machine.
And really, this is the key thing to remember. As the saying goes, the user program is where the blueprint becomes a bespoke creation tailored to a specific task. Everything we've done up to this point was about building a solid, standard foundation. This is where you turn it into something truly unique.
Okay, the code is written, the digital mind is built. There's only one thing left to do. It's time to go live. We need to deploy this thing from our computer to the actual controller and bring this machine to life.
When it comes to deployment, you've basically got two options. First, you can go the virtual route with PLC SM Advanced. This is awesome for testing everything safely without touching any real hardware. All you have to do is check the Activate Simulation box. The other option, of course, is the real deal, downloading to the physical machine. But before you do that, it's a really good idea to do a full PLC reset, just to make sure you're starting with a completely clean slate.
Now, a PLC reset sounds way more complicated than it is. It really just comes down to 3 key moves. 1. Flick the PLC mode switch to stop. 2. Do the little MRES sequence. You just move the switch to MRES, wait for the light, let go, and hit it again really quick. And 3. Switch it back to run. That's it. You've just wiped the memory and it's totally ready for your new program.
And then, after a successful download, you get that magic moment. Everything you built digitally, that whole blueprint in the TIA portal, is now alive and running on the real hardware. Software and hardware are perfectly in sync. The machine finally has its mind.
So let's just take a quick look back. We started with an empty project, we grabbed our tools, we built the hardware blueprint, we plugged in the core program, and then we built our own custom logic right on top of it. We literally went from a blank slate to a fully functioning mind for the machine. And that really brings us to the most exciting part. We've gone through the whole process from A to Z. You now have the blueprint. You know how to build the mind of a machine. So the only question left is, what are you going to make your machine do?